Penguin Random House Audio presents Blue Machine, How the Ocean Works. Written and read for you by Helen Czerski.
For my sister, Irena. Introduction. Equator. Our canoe floats quietly in the darkness, a tiny, drifting speck dwarfed by the starry sky. We wait while deep, inky blue crawls upward from the horizon, gently extinguishing the stars as it reveals the gigantic silhouette of Haleakala, the larger of Maui's two dormant volcanoes. The support boat bobs a few meters away, between us and the eastern horizon. I'm in the fifth seat from the front in a six-person outrigger canoe, and the armour, the second floating hull that connects these canoes to the ocean like no other craft, rides the water to my left. The water is flat calm, and the peace is immense. We wait. Just before the first hints of pink light wash around Haleakala, it's time. Kimokeo Kapahuluhua stands up on the side of the support boat, facing the canoe, wearing shorts and a t-shirt and a tea-leaf lei. He calls out to us in the canoe and to our teammates on the support boat. I know very few Hawaiian words, but I can follow along because this is a familiar expression of a deep Hawaiian connection to the ocean. The canoe isn't just a physical object designed for a practical purpose. Every aspect of a canoe is a symbol of teamwork, to make it, transport it, paddle it and maintain it, and it's teamwork that holds these island nations together. This is about ohana, the extended family, and about taking care of the people in your canoe. The ocean is as much a part of home as the land. It's changeable and it can be hazardous, but if you show humility and you observe and learn, the ocean will support you and provide for you. Today we are setting out on a voyage around Maui's second volcano, Mauna Kahalawai, from here in Kahului Bay all the way around to Kihei. But we need skill and weather and luck with ocean conditions to complete the trip. Whether or not we succeed, it's the time spent together and what we learn on the way that's important. This ritual reminder lasts only a few minutes, because here at the equator the sun rises quickly. As bright lilac and pink fill the sky behind Haleakala, Kimokeo finishes with a chant, and we all join in. E ala e is the first and most significant chant that any Hawaiian child learns, intended for this vital moment when sunlight first touches the ocean and everything can begin. Under the clear sky, we can almost feel the day's flood of intense sunlight on its way. Cam, steering the canoe from the sixth seat just behind me, calls out, "Hoama kau kau," and we raise our paddles. They hang in the air for one last moment of stillness as the first shaft of bright sunlight touches the ocean ahead of us. Then, imua, and six paddles cut into the water simultaneously. The voyage is underway. Pole. 5 months later, I'm lying on my tummy on the edge of a giant ice floe. An ice floe is a sheet of floating ice. At 2 kilometers across, this one was unusually large. Most are much smaller. My colleague Matt is standing on a 3-meter square wooden platform, floating on the ocean, and I'm attaching a rope to the side of it. The water is minus 1.8 degrees Celsius, technically much warmer than the air, which today is minus 8 Celsius, but far more effective at stealing heat, so I'm focused on keeping my fingers and the rope dry. The platform has a squat, round metal dome rising from its centre, and the rest of the platform is a hive of mechanical servants tending to the dome's needs, large metal boxes and batteries, exchanging data, electrons and air with the queen bee in the centre via chunky cables. This is Matt's experiment, designed to capture and count any tiny particles that the ocean is spitting into the atmosphere. I tug on my new knot and stand up, checking that nothing has fallen out of the pockets of my heavy flotation suit. When I nod, Matt strides off across the ice floe to fetch some helping hands. the cheerful bouncing of the bobble on his hat taking the edge off any serious polar scientist look he might have aspired to. I spend a few minutes just looking at the view, a rare treat. 2 kilometres away, on the other side of the ice floe, I can see the Swedish icebreaker Odin, our home for these 2 months. Towards the middle of the ice floe, a large, tethered red and white balloon, the size of a small camper van, bobs in the sky with today's scientific experiment dangling beneath it. In the other direction, the white sea ice stretches away for hundreds of miles. We're only a few nautical miles from the North Pole, and the summer sea ice here is about 2 meters thick. The ice floes around ours shunt and grumble, moving slowly, but just enough that our worksite looks different every morning. This afternoon the clouds are lifting to reveal rare blue sky directly above, but sunlight will never beam down from that space. The sun here slinks around the horizon, but never drops below it, casting astonishingly long shadows when the clouds allow. Even though this spot is in the middle of 6 months of constant daylight, the sunlight feels purely decorative, a cascade of soft, subtle illumination which will never keep you warm. The energy flow here is mostly invisible, directed upwards, not downwards. Around me, the Earth itself is glowing, radiating infrared light as what little heat it has seeps away into the sky. Without the clouds as an obstacle, this heat energy will just keep going out into space. A clear day today means a cold day tomorrow, as the ice and the ocean lose their energy to the universe. This process is a crucial entry in the Earth's energy budget, but we still can't predict it exactly. On this ice floe, we're in the middle of these mechanisms, surrounded by liquid clockwork, and we want to know. The cohort of scientists on Odin is here to observe, measure, and analyse this spectacular environment, to use the latest equipment and logic to deduce the inner workings of the ocean and atmosphere. Matt returns with 3 of our colleagues. Out in the natural environment, data are hard won, and that often means very physical effort. We want the platform to be floating away from the ice edge so it can take measurements in open water. Hauling on long ropes in teams, and with much grunting and shoving, we manoeuvre the platform away from the edge and watch to see whether it will stay put. Once we're happy, we anchor it in place and prepare to return to the ship. Beneath the ice we're standing on, the ocean is deep and dark, quiet and cold, always there, but only rarely the centre of attention. The Earth's oceans are vast, and yet they often seem invisible. We had to go into space to really appreciate that the defining feature of our planet is not land, but water. The Apollo program sent men to the moon, but I think that its most significant achievement was to let all of us see the Earth. 2 of the most influential photos ever taken shifted our perspective forever. Earthrise, taken in 1968 during Apollo 8, and the blue marble, taken in 1972 during Apollo 17. Once you've seen them, you can't unsee that view and its significance. The fragile blue sphere floating in the cosmos with everything we've ever known on board. But even then, the blue was seen as the canvas on which the land was drawn, the emptiness between the great continents, and a mystery that could probably wait until after all the important stuff was sorted out. 50 years on from Apollo, humans are finally starting to pay proper attention to what's inside those vast blue expanses. It's overdue, but those forays into space gave us the necessary starting point, a blank map to fill in. Maps of the Earth are rich and astonishing treasure troves, and globes are even better. The anatomy of our planet is full of fascinating detail: coastlines, mountain ranges, rivers and island chains, full of patterns and yet still so varied. It seems endless because it is. The more closely you look, the more there is to see. Lumpy continents give shape to the blue oceans, and we split our home planet into land and sea. It's not.
Sample complete. Ready to continue?